sorry, on Thursday we did up to this slide, right? So today there are some homework that need to be done by you. So what is that? 16 to 1 line multiplexer you have to design from a 4 into 1 line multiplexer. So how can you do that? You have learned how to do this, right? And then again 32 to 1 line multiplexer needs to be designed by 8 to 1 line and 4 to 1 line multiplexer. So can you do that, or I have to explain how to make these things? Will you be able to do this, or I have to explain how to?
Can you please explain?
Okay, so if you need to make 16 to 1 line multiplexer, so let me duplicate this slide first, and I need to remove this portion. Okay, I have to make a 16 to 1 line multiplexer from a 4 to 1 line multiplexer. So 16 multiplied by 1, I have to make it from 4 into 1 multiplexer. So what I need to do first, 16 divided by 4 gives you 4, right? Again 4 by 4 gives you 1. So this will be my first stage. This will be my second stage. So in my first stage, how many multiplexer should be here? 4, right? 4 into 1 marks 1. Then again 4 into 1. Then again 4 into 1 marks 3. And then 4 into 1 marks 4. So for 16 to 1 line multiplexer, what would be my truth table? So I will have 16 multiplexer. So how many control input should be there? 4, right? S3, S2, S1, S0. And if you see output F, then the combination can start from 0, 0, 0, 0, and the output should be I0. Then 0, 0, 0, 1, the output should be I1. Then it should go up to 1, 1, 1, 1. My output would be I15, right?
Yes, sir.
We have discussed that in our previous class, right? So
Yes,
now
sir.
Yes, sir.
for this multiplexer, my input should be 4 input, should be I0 to I3. So I0, I1, I2, I3. Then here it should be I4, I5, I6, I7. Then here you should have I8, I9, I10, I11. And then for the last multiplexer, it should be I11, I12. Did I make any mistake? 8, 9, 10, 11. Oh, sorry, it should be 12, 13, 14, 15. Now, this output should be Y1. This output should be Y2. This output should be Y3. And this output should be Y4. and this 4 output should come to another multiplexer 4 into 1 mask 5, and this should come as the first input, this should go as the second input, this should go as the third input, and this should go as the 4 input for the multiplexer, and then the output of the multiplexer should be Y, right?
Yes, sir.
Now you have two control input, so for each and every multiplexer, this multiplexer, 4 multiplexer, the control input should be what? S1, S0, right? And here also the control input should be S1 and S0. And for this multiplexer, the control input should be S3, S2. So the whole thing will be working as a 16 to 1 multiplexer. So if you want to see one demo, I can give one demo. So suppose the demo should be, I am just considering one case 1000. That's mean the output should be I8, right? So for this combination, what is the value for S1 and S0?
0.
0, right? So this should become 0, this should become 0. Similarly, this should become 0, this should become 0, this should become 0, should become 0, this should become 0, and this should become 0. So what will be the output for multiplexer 1?
I0.
I0 for this one. And for the multiplexer 2,
I4.
I4, right? And for this multiplexer,
I8.
I8. And for this multiplexer, I12, right?
Yes, sir.
Now, for this multiplexer, S3 and S2 is the control input. So what should be the value for S3? 1, and S2 for 0. So for this input, what should be the output of this multiplexer? The third one, right? So this third one is what? I8, right?
Yes, sir.
So similar way, I think you can also do 32 one line multiplexer by 8 to 1 line and 4 to 1 line multiplexer, right? So try this at home. So the next thing that I will try to explain today that you need to do in the exam. Suppose you have a truth table given like this, and they say you have to implement this truth table by 8 into 1 multiplexer. So you need to implement this truth table using a 8 into 1 multiplexer. So how can you do that? So first, my truth table is what? Truth table should have 3 inputs, right? What is that? C, B, and A, and the function output is Z. So 0, 0, 0, it should be, okay, I am writing it 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and then 1, 1, 1. So what should be the output for 0, 0, 0? It should be 0, right? Then for 0, 0, 1, it should be 1. Then for 0 1 0 it should be 1. Then 0 1 1 it should be 0. Then 1 0 0 it should be 0. Then 1 0 1 it should be 0. Then 1 1 0 it should be again 0, and for 1 1 1 it should be 1. So can you remember the multiplexer truth table? What was the multiplexer truth table? So for the multiplexer 18 to 1 multiplexer, how many control inputs should be there? 8, right? S3, S2, S1, and the multiplexer output should be your Z. So we know 0 0 0, when we putting that, the output should be I0. Then if we say 0 0 1, then output should be I1. Then if it is 0 1 0, the output should be I2. Then 0 1 1, the output should be I3. Then 1 0 0, the output should be I4. Then 1 0 1, the output should be I5. Then 1 1 0, the output should be I6. And then finally, when it is 1 1 1, the output is I7, right?
Yes, sir.
So now if you compare this both truth table, so here if we make C as S3, if we make B as S2, and then if we make A as S1, then the control inputs here, it will be same as here, right? So what will happen? This will become my I0, this will become my I1, this will become my I2, this will become my I3, this will become my I4, this will become my I5, this will become my I6, and this will become my I7, right? So what they have given here, they put this control command, likewise I said. So sorry, here it should be S2, S1, S0, right? So S2, S1, and then S0. So as you can see, C is given to S2, B is given to S1, A is given to S0, and your I0 is kept at 0 potential. I0 is kept at 0 potential. Similarly, what are the other input that are kept at 0 potential? I3, I4, I5, I6. So it goes to also I3, I4, I5, and then I6. Then which are the inputs which should be connected to 1? I1, I2, and I7. So here you can see your I1, I2, and I7 is connected to your source through a variable resistor. So do you understand this? Is there any question?
No, sir.
Can I go to the next slide?
Yes, sir.
Okay. So now we have been said to implement this truth table using a 4 into 1 multiplexer. So what the 4 into 1 multiplexer looks like? So if you have a 4 into 1 multiplexer, the input should be what? I0, I1, I2, I3, right? Control input should be S1 and S0 and output should be Y, right?
Yes, sir.
What is the truth table for 4 into 1 multiplexer? So if you have S2 and S1 and your output is Y, so for 0, 0, the output should be I0, 0, 1, output should be I1, for 1, 0, output should be I2, and for 1, 1, the output should be I3. So here I have how many in the truth table? How many inputs I have? 4, right?
Sir, isn't that S0 and S1, sir?
Sorry,
Isn't that S0 and S1?
sorry, S1 and S0, right? Okay. So now here I have 4 inputs. So among these 4 inputs, if I consider A3 to be my S1 and A to be my S0, so what will happen that for up to this part, you can see S1 is 0 and S0 is 0, right?
Yes, sir.
Right?
Yes, sir.
Yes, sir.
So according to this truth table, what should be your output? I0, right? So this should be your I0. Is that clear?
Yes, sir.
Again, these 4 values, for these 4 values, your S1 is 0 and S0 is 1, right? So whenever you have S1 0 and S0 1, what should be the output?
I1.
So this 4 corresponds to I1, right? Are you getting my points?
Yes, sir.
So for the next 4, you have S1 1 and S0 0, right? So this is the third combination for which your output should be
I2.
I2, right? And for the last 4, it should be S1 equals to 1 and S0 equals to 1, right?
Yes, sir.
So up to this 4, among the 4 input, you have already considered these 2 as the control input, right? So the next 2 I can use as a input. So how can we do that? We can do that using the K maps. So if I consider the K maps for 4 values, suppose this is the K maps for I0. So what will be the input for that? A1 and A0. So where I should put 1, the last 2 1, right? Right? So 0 0 gives 0, 0 1 gives 0, 1 0 gives 1, and 1 1 gives 1. So where should I put 1? The last 2 square, right?
Yes, sir.
Yes.
It should be 0 1 0 1. So what should be the outcome for our I0? So how can we combine them? What is common for that?
I1, A1.
It should be A1, right?
Yes.
A1 should be connected here directly. Now for I1, what would be my K map? For I1, again, for I1, again A1 and A0 is my input. So 0 1 0 1. So where should I put 1? Again the last two, right?
Yes, sir.
So again if you combine them, your I1 should be
A1.
right.
Yes, sir.
So it should be also your A1. Then if we do the KMF for I2, so what should be, where should I put 1? The first one and the last two one, right?
Yes, sir.
So how can we combine them? These two in a group and these two in a group, right?
Yes.
Should be your I2 equation.
A0 plus
A1,
A1
plus
A1 bar,
A0.
zero bar,
A0
right?
bar.
So your I2 should be, so if you can say this is your A1, so from A1 and then it should be I0 bar. So from I0 you need to have a NOT gate and they should be OR together, right?
Yes.
It should be connected to I2, right?
Yes,
Yes,
sir.
sir.
And the last one, and the last one, it should be I3, A1 along this direction, A0 along this direction, 0 1 0 1. So what should be I3? Where should I put?
Second place and fourth place.
So we cannot combine them, right?
Yes, sir.
So what should be your I3? For this one, we can write A1 bar A0 plus, for this one we can write A1 A0 bar, right?
Yes, sir.
So what should be this value? A1 A0
XOR
or A0, right?
Yes,
2.
sir.
So again, if you have A1 and A0, it should be connected to a
XOR gate.
XOR gate and that should be connected to your I3. Make sense?
Yes, sir.
Okay. So similar way, a truth table is given and you are told to implement this truth table using a 4 into 1 multiplexer. So for 4 into 1 multiplexer, 4 into 1 multiplexer, first I will suggest you to draw the multiplexer diagram first and it will give you a clear picture. So 4 into 1 multiplexer, how many control inputs should be there? 2, right?
Yes, sir.
0. And the input should be 4.
Yes, sir.
Which are
I0.
I1, I2 and then I3 and your output should be F since we are using F here. So now what is the truth table for 4 into 1 multiplexer? Your control input is S1, S0 and output is F. So for 0, 0 it should be I1. For 0, 1 it it should be
I0 হবে।
it should be I1. For 1 0 it should be I2 and for 1 1 it should be I3, right?
Yes, sir.
So now if we consider W1 equals to S1 and W2 equals to S0, so I can combine for these two, my S1 is 0 and S0 is 0, right?
Yes, sir.
So these two should correspond to I0, right?
I0.
Again, if we divide it for these two, S1 should be 0 and S0 should be S0 should be what?
1.
1. So these two actually corresponds to I1, right?
Yes, sir.
Similarly, these two corresponds to,
I2.
I2.
and the last two corresponds to
I3.
I3, right? So
Yes, sir.
among the three inputs, we have already considered the first two as the control command, right?
Yes, sir.
So now the only input remaining is W3, right?
Yes, sir.
So now for single input, can we do the K-map?
No.
So we'll try to find the relationship between W3 and F. So whenever W3 is 0, output is 0. Whenever W3 is 1, output is 0. So the output here is not dependent on W3, right? And the output is always what?
0.
0. So here, the first input, I0, it should be connected to 0 because in both cases, the output is 0, right?
Yes, sir.
Now, for the second case, for I1, whenever W3 is 0, output is 0. Whenever W3 is 1, output is 1. So the output exactly matches with the W3, right?
Yes, sir.
So here for I2, what we can do, we can directly connect W3 as I2, right?
Yes, sir.
I1. For I1, we can directly connect W3 as I1, right? So for the next two, again you can see whenever W3 is 0, output is 0. Whenever W3 is 1, output is 1. So for I2 also we can write is at W3, and W3 can be connected directly to W2, right? Sorry, I2. And for the last two part, last two inputs, whenever W3 is 0, output is 1. Whenever W3 is 1, output is also 1. So this output doesn't matches with W3. So it will not be dependent on W3. So I3, it should be always 1, right? Because for this combination, output is always 1. So here you can see for I3, it is connected to 1. Is that clear to you all?
Yes, sir.
Any question? Can I go to the next slide?
Yes, sir.
Now, it is said that you need to implement an online AND logic gate using 2 into 1 and 4 into 1 multiplexer. So what is the AND gate truth table? Suppose for AND gate you have two inputs A and B, and what is the AND gate output? Whenever it is 0 0, the output should be 0, right? Then whenever it is 0 1, output should be 0, right? Whenever our input is 1 0, output should be 0. When it is 1 1, the output should be
1.
that is the truth table for AND gate, right?
True, sir.
So we have to implement this AND gate first using 2 into 1 multiplexer and then 4 into 1 multiplexer. You are getting what we are trying to do, right?
Yes, sir.
So if I want to make this truth table using 2 into 1 multiplexer, so for 2 into 1 multiplexer, what is my input?
I0,
I0 and
I1,
I1, right? And what is my control input? S0,
S0.
and F will be my output, right?
Yes,
Yes,
sir.
sir.
You can say Z will be my output, right? So how can we do that? So what we can do here, so here if we write the truth table again, A, B, and this is my Z. So for 0, 0, the output should be 0. For 0, 1, the output should be 0. For 1, 0, the output should be 0. And for 1, 1, my output should be 1. So now since it has only one control knob, so if I consider A to be my S0, so for these two value, my S0 is 0, right? And for these two value, S0 is 1, right?
Yes, sir.
So for these two values, since if you match with this truth table S0, so whenever your input is 0, the output should be I0, right? Whenever S0 is 1, your output should be I1, right? Right? So if we compare these two table, so these two element gives you I0, right? And these two gives you,
1.
right? So we have two inputs, and between them we have already considered A as your
Control bit.
control bit, right?
Yes.
So only thing left is B. So we'll try to make a relationship between B and Z. So here if you see, whenever B is 0, Z is,
0.
whenever B is 1, Z is 0. So I0, will it be dependent on B?
Independent.
Independent, and I0 should always be 0, right?
Yes, sir.
But for I1, you can see whenever B is 0, output is 0. Whenever B is 1, output is 1. So your I1 should be
1.
exactly same as B. So what will be your 2 into 1 multiplexer? So your I0
0.
should be connected to ground, right?
Yes, sir.
And your I1 should be connected to
B.
B, right? And here your control input should be A and your output should be Z, right?
Yes, sir.
So the same thing, how can we do that using 4 into 1 multiplexer? So for 4 into 1 multiplexer, 4 into 1 multiplexer, your input should be I0, I2, and then I3, right? And output should be Z. So, and here you should have control input S1 and S0, right?
Yes, sir.
So, for S1 and S0, if you draw the truth table S1 and S0, and suppose this is your output Z, so how many combination can we get? 0 0 0 1 1 0 1 1, right?
Yes.
And here it should be I0, I1, I2 and I3, right? So if we compare this truth table and this truth table, what will happen? So what I have to do? We have to make, if we take A, B and Z, again 0 0 0 1 1 0 1 1. So here we have value 0 0 0 1. So if we compare them together, if we take A as S1 and B as S0, so what will happen? This becomes my I0, right? This becomes my I1. This becomes my I2. And this becomes my I3, right?
Yes, sir.
So what will be the multiplexer input then? So here, what we can do? It should be 0 0
0,
and then 1, right? And for the control input, what we can do? These two control input will be replaced by A and B, right?
Yes, sir.
Any confusion so far? So, similarly, you have been told to implement 3 input OR gate XOR using 2 into 1 and 4 into 1 multiplexer. So, try this at home. Homework. So for the last one, I think this is the last one, the multiplexer thing, and then we will be doing some applications of multiplexers. So they, you are told to implement this circuit, this truth table using a 2 into 1 multiplexer. So how can we do that? So for 2 into 1 multiplexer, input should be 2, right?
I0, I1.
Sorry. 2 into 1 marks, input should be I0 and I1, right?
Yes, sir.
S0 and your output should be F. And the truth table, it should be for S0 and F, whenever it is 0, output should be I0. Whenever it is 1, output should be 1. So how many inputs we have? 3 here. So if we divide it by 2, and here you can see for these 4 you have 1 0 here. So if we consider S0 as W1. So for this part, we can write this is H0 equals to 0. And for the next 1, we can write H0 equals to 1, right?
Yes, sir.
So these 4 actually representing I0 and these 4 actually representing I1, right?
Yes, sir.
So among the 3 inputs, we have only used one input as the control input. So how many left?
2.
So now since we have 2, so we can do the K-map, right?
Yes, sir.
So if we try to do the K-map for I0, what will be my input? W2 along this direction and W3 along this direction, 0, 1, 0, 1. So now where I should put 1? The last one, right?
Yes, sir.
So we can write simply I0 is your W2, W3, right?
Yes, sir.
So here you can see this is my I0. So W2 and W3 is doing an AND gate. So it should be W2, W3, which should be equals to my I2, I0, right?
Yes, sir.
And for my I1, again, if we take W2 and W3, 0, 1, 0, 1. So where I should put 1?
Second, third, and fourth.
So how can we combine them? These two together and these two together, right?
Yes, sir.
So what will be my equation for I1?
W2.
W2 plus W3.
So they are all together, right? And that should be your I1. And W1 should be your control input, right? Any question? So that will be the syllabus actually for the midterm exam, which is supposed to held at
27th. 27th April.
27th April. And there are 2 applications of multiplexer. I will discuss that in the class later. Okay. So these 2 applications will not be in your syllabus for the midterm. So whatever we have done so far, if you have any questions, you can ask, or else you are